All right, let's crack open the so-called black box and see what's really going on inside the mind of an AI. Today, we're going to explore the different blueprints, the actual architectures that let an AI see the world, make a decision, and then, actually do something.
I mean, seriously, have you ever watched a self-driving car navigate a crazy intersection? Or seen one of those little robot vacuums map out your entire house and just thought, how? How is it doing that? What is the actual thought process there? It can feel like some kind of magic, but it's really not. It's all about a specific engineered design, a blueprint for how to think.
Yeah, that design really is the blueprint for an artificial mind. So to make sense of it all, we're going to frame this whole thing as climbing a ladder of intelligence. We're going to start on the very bottom rung with the most basic AI minds and then work our way up, step by step, to the agents that can actually learn and adapt all on their own.
Okay, so before we take that first step up the ladder, we got to get on the same page with a key term, the intelligent agent. This is the core concept for everything else. At its heart, an agent is just anything that can sense its environment, using things like cameras or microphones, and then act on it, using wheels or robot arms, or even just changing pixels on a screen. A self-driving car? That's a super complex agent. Your smart thermostat? Yep, that's an agent too, just a much, much simpler one. All right, boots on the ladder. Let's take our first step. We're starting at level 1 with the most basic kind of intelligence you can imagine. Agents that are all about pure, simple, unthinking reaction.
And right here, at the very bottom, we find the simple reflex agent. This is the absolute foundation, the most bare-bones blueprint for an AI mind you could possibly build.
This agent's thinking is pure instinct. It's all based on a simple if this, then that rule. It only looks at the world as it is right now and completely ignores everything that happened before it. For that robot vacuum, the rule is simple. If my bumper hits a wall, then I turn. But this leads to its huge glaring flaw. It has absolutely no memory. And because it can't remember the chair leg it bumped into a second ago, it can get stuck in a loop, just bumping back and forth and back and forth forever.
So yeah, that whole no memory thing, it's a massive problem. It's a hard limit on its intelligence. An agent that only sees the present moment is easily fooled and very easily trapped. To get any smarter, it needs a way to remember the parts of the world it can't see right now. So, the big question is, how do you give an AI a memory?
Well, the answer is on the very next rung of the ladder. We solve the memory problem with the model-based reflex agent.
And wow, this is a game-changing upgrade. This agent keeps an internal state. You can think of it as its own little mental map of the world. So now our robot vacuum isn't just reacting to bumps anymore, it's actually building a map of the room as it goes. It understands that the chair it saw a minute ago is probably still there, and it knows how its own actions, like moving forward for 3 seconds, will change its position on that map. This ability to handle a world where it can't see everything at once is a massive leap in smarts.
Okay, so let's recap. So far, our agents can react to the world, and they can even remember it. But they don't really want anything. They don't have any ambitions. That brings us up to level 2 on our ladder, agents that don't just act, they act with a clear purpose.
And that's where the goal-based agent comes in. Now things start to feel a lot more intentional and a whole lot smarter.
See, unlike those reflex agents, a goal-based agent knows 2 critical things: where it is right now and where it wants to be. It then uses some pretty complex ideas like search and planning to figure out how to get there. Search is like exploring all the possible routes on a map in its head, and planning is picking the best sequence of moves to actually make the trip. The beautiful thing about this is its flexibility. If you tell a self-driving car your goal is the airport, it plans a route. If you suddenly change your mind and say, nope, take me to the train station, you don't have to reprogram anything. You just give it a new goal and boom, it figures out a new plan.
But wait, this brings up a whole new problem, right? For this agent, success is just binary, yes or no. Did I get there or not? But in the real world, not all paths are created equal. What if one route is faster but way more dangerous, and another is slower but much safer? How does it choose the best way?
To answer that question, we have to climb even higher on our ladder, all the way up to the utility-based agent.
So just look at this, it makes it super clear. Path A gets you there in 10 minutes flat, but it's not very safe. Let's give it a utility score of 6 out of 10. Now, path B is a little slower, 12 minutes, but it's much safer, giving it a higher utility score of 9. A simple goal-based agent, it would probably just go for path A. Fastest, right? Done.
But the utility-based agent is smarter. It can weigh these factors and see that path B is actually the better, more rational choice overall.
And the magic behind this is something called a utility function. You can literally think of it as a happiness score for the AI. It's a way for it to measure how satisfied it would be with any given outcome. So in a complex world full of uncertainty, it doesn't just do something that gets it to the goal. It chooses the action that it predicts will give it the highest possible happiness score, making the most rational bet for the best possible result. Okay, let's take a breath. We've climbed all the way from basic knee-jerk reactions to complex, rational decision-making. But here's the catch. All of these agents we've talked about, they still only know what a human programs into them. So what's the ultimate upgrade? Well, it's not just another rung on the ladder. It's more like a jetpack for the entire thing. The ability to learn. I mean, really think about it. What happens if you take one of these pre-programmed agents and just drop it into a world it has never ever seen before? It would be totally lost, right? Its internal models, its rules, all of it would be useless.
The answer is the learning agent. But here's the key thing to get. This isn't really a new type of agent. It's more like a powerful upgrade package, a mod you can install on any of the others. You can have a learning goal-based agent or a learning utility-based agent. It's an upgrade that lets them get better all by themselves just through experience.
So how does this learning thing actually work? Well, it's got 4 main parts. And honestly, the best way to think about it is like you're learning to play a new video game. First, the performance element. That's you, with the controller in your hand, just trying to play the game. Then you've got the critic. That's like the score screen at the end of the level, telling you how well you did. That feedback goes to the learning element, which is your brain, going, okay, note to self, don't jump in that pit next time. It updates your strategy. And finally, you have the problem generator. That's your own curiosity, that little voice that says, I wonder what happens if I try going down this secret path. It pushes you to explore to find even better ways of winning. Altogether, these 4 parts create a powerful feedback loop for constant self-improvement.
So there you have it. We've made it to the top. We've climbed the entire ladder of AI minds, from the absolute simplest reactions to the incredible complexity of self-directed learning. Let's just do a quick run-through of the journey.
Remember where we started? With the simple reflex agent that just acts on pure instinct. Then we gave it a memory, creating the model-based agent. We gave that agent a purpose, which got us the goal-based agent. Then we gave it the wisdom to weigh its options, creating the utility-based agent. And finally, we strapped a jetpack to the whole thing with the learning agent upgrade, letting any of them improve all on their own.
And so, climbing this whole ladder, it leaves us with one final massive question, maybe the biggest question in all of AI. These blueprints show us how to build intelligent minds, but they don't tell us what to build them for. Now that we can design agents that learn and can relentlessly get better at achieving a goal, the most critical challenge we face is making sure we give them the right goals in the first place. Something to think about, right?
Thanks for digging into this with me.